Hilong-hilo ka na ba dahil math hirap ang lessons nyo? Math dali lang yan. Mag-subscribe ka lang sa channel ko at malalaman mo that math is fun. Welcome back to my channel and welcome to another Math Daling lesson. So for today, we're gonna talk about finding GCF or finding greatest common factor using three methods. So the first one is listing method, the second one is the prime factorization method, and the third one is the continuous division method. So if you're interested, please keep on watching. Okay, so first is we are going to discuss finding GCF using listing method. As the title of the method itself, it means that we are going to list down the factors of our given. Let's start with 9, 30, and 12. So we are going to find the GCF of 9, 30, and 12 using listing method. So let's start with listing the factors of 9. So what are the numbers that if we multiply together, the answer would be 9? So we have 9 and 1, since 9 times 1 equals 9. And also 3 times 3. So we're just gonna write 1, 3. So the factors of 9 are 9, 1, and 3. So now we are going to list down the factors of 30. What are the numbers that if we multiply together, the answer is 30? So 30 times 1, it means that 30 and 1 are factors of 30. And then 2 and 15. We also have 6 and 5. And also 3 and 10. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now we are going to proceed with 12. So we're gonna write down 12 and 1. 2 and 6 are also factors of 12. And also we have 3 and 4. So the factors of 12 are 12, 1, 2, 6, 3, and 4. So we already list down all the factors of our given. Now we are going to look for the highest or the greatest common factor of 9, 30, and 12. So what are their common factor? So 1 is their common factor, and also 3 is their common factor. So which is greater than 1 or 3? Of course, the answer is 3. Therefore, the GCF of 9, 30, and 12 is 3. Our next example, we have 15 and 50. What is the greatest common factor of 15 and 50? We are going to solve it using listing method. Let's start with 15. So what are the numbers that if we multiply together, the answer would be 15? So we have 15 and 1. We also have 3 and 5. So the factors of 15 are 15, 1, 3, and 5. Now we are going to list down the factors of 50. We have 50 and 1. We also have 2 and 25. And also we have 5 and 10. So the factors of 50 are 50, 1, 2, 25, 5, and 10. So we are gonna look for the greatest common factor of 15 and 50. So 1 is their common factor. We also have 5 as their common factor. So which is greater than 1 or 5? So the answer is 5. Therefore, the GCF of 15 and 50 is 5. Now we are going to proceed with our next method, which is prime factorization. It means that we are going to factorize all our given until all the factors will be equal to prime number. If you have no idea what is prime number, I did a tutorial on it. I will just put the link on the description box so that you can check on it. So our first example is 21 and 42. So we are going to look for the GCF of 21 and 42 using prime factorization. So let's factorize 21. So we have 3 and 7. So since 3 and 7 are already prime numbers, we are going to stop with it. Next is 42. So we have 6 and 7 because 6 times 7 equals 42. So we all know that 7 is already prime number, but 6 is still a composite. So we're still gonna factor 6. So 6 is 2 times 3. And 2 and 3 are already prime numbers, so we're gonna stop with it. So we're gonna look at the side of 21 and 42. What are the common factors? So we have 3 here, and we also have 3 here. We have 7 here, and we also have 7 here. So we don't have 2. So it means that their common factor is 3 and 7. So we are going to multiply 3 and 7. So 3 times 7 equals 21. Therefore, the GCF or the greatest common factor of 21 and 42 is 21. Our next example is 6 and 10. So we are going to look for the GCF of 6 and 10 using prime factorization method. So first, we are going to factorize 6. So 6 is 2 times 3. So 2 and 3 are already prime numbers. So we're gonna stop with that. Next is 10. So factors of 10 are 2 times 5. So since 2 and 5 are already prime numbers, we're gonna stop with it. So let's look at the side of 6 and 10. What are their common factor? We're gonna look for the common factor of 6 and 10. So we have 2 here, and we also have 2 here. Since only 2 is the common factor of 6 and 10, therefore, their GCF is equal to 2. Our third and final method is continuous division. It means that we are going to divide the given until the only factor that is left to them is 1. So let's start with 21 and 70. So what is the common factor of 21 and 70? So we have 7. So 21 divide by 7, the answer is 3. 70 divide by 7, the answer is 10. So there's no other number that can be divided by 3 and 10. That's why we're gonna stop with it. Therefore, the number here is the GCF or the greatest common factor of our given, which is equal to 7. So the greatest common factor of 21 and 70 is 7. Our next example is
12, 36, and 16.
Now we are going to proceed with finding the GCF of 12, 36, and 60 using continuous division. So let's divide the given with 2. 12 divided by 2 equals 6. 36 divided by 2 equals 18. 60 divided by 2 equals 30. Now we are going to divide the given with 3. 6 divided by 3 equals 2. 18 divided by 3 equals 6. 30 divided by 3 equals 10. So 2, 6, and 10 can still be divided by 2. 2 divided by 2 equals 1. 6 divided by 2 equals 3. 10 divided by 2 equals 5. So we cannot divide 1, 3, and 5 by other number other than 1. So we're gonna stop with it. So all these numbers on this side will be multiplied. So 2 times 3 times 2 equals 12. So therefore, using continuous division, our GCF is equal to 12. Okay, so that's it for today. So please give this video a thumbs up, and you can also share this video to your family and friends. Don't forget to comment down below, and don't forget to click on the subscribe button and also the notification bell so that you'll be updated every time I upload a new video. Thank you so much for watching.
Peter Pan, that's what they call me. I promise that you'll never be lonely.